Hey gang, this is Dr. Jerry A. Smith. Welcome to Dr. J's Forays into Data Science. This week, indicative of nothing whatsoever, I'm going to show you how to integrate R, that awesome, awe-inspiring statistical processing environment, with Hadoop, the master of distributed storage and processing. And we're going to be doing all this with three great capabilities from Revolutionary Analytics. What capabilities, you dare ask? Well, we're going to be using RHbase, RHDFS, and RMR2 libraries for R, which are supplied by, free of charge, Revolutionary Analytics. Once done, we're going to apply this R Hadoop environment to count the number of words in that massive classical book, Moby Dick. Here, let me show you exactly how all this is going to work. The first part in integrating R and Hadoop is to create a designated Hadoop user on our system. So I'm going to go up under the Apple menu, I'm running Mac, and select System Preferences. From there I'm going to go down to the Systems row and click on the Users and Groups. Notice I already have a Hadoop admin user here, but I'll create one from scratch by authenticating so I can make an administrative change by typing in my password. From there I'll click the plus sign, which is going to be the Add New Users to my system, Add New User account. I'm going to create an admin user by selecting admin under the new account. I'll type in the name, Hadoop, and you'll notice it's going to show up in red here as I type because I already have one. I'll add the account name itself, which is Hadoop, and then I'll add my appropriate passwords. And from there I would normally click Create User, but in this case I'll just cancel out. Now that I have my Hadoop user created, I usually like to add a specific icon here. I open up any browser of your choice. In this case, Bing. I just type in Hadoop. I go up under, once I've done the search, I go up under Images. I scroll down, find a particular graphic I like. Oh, here's one. I like this little guy here. So I'm just going to scroll this down. I'm just going to drag it right over my icon for my Hadoop user. Scale it down a little bit here. I think I'll keep this one. Yeah, I like this one. Click Done, and I'm done. And now I have a brand new Hadoop user on my system. Our next activity is to make sure that we have the right version of Java installed on our machine. So I'm going to go off screen, go into Spotlight, type in terminal, bring up a terminal, size it out here a little bit, and then type in Java version, see what version we have. And we're running, looks like we're running 1.6, which is fine. I understand that 1.5 or 1.6 will do just fine for integrating R Hadoop with Hadoop itself. If you don't have the right version, you're going to need to go to either update your Mac OS or go to Oracle and download Hadoop itself and run an install process there. The next thing we need to do is make sure that we set up a remote desktop and enable self-login. So I'm going to head up to the Apple, select Preferences, and then go down to the Internet and Wireless row and select Sharing. From there I'm going to ensure that my remote login is selected for this particular user. It's under the Sharing dialog. I've set it up for Hadoop already, but I've also added my own personal account so that I can remote access from my personal account as well. Now we're going to configure the system so that we can log into localhost without asking for a password. So I go off screen, bring up terminal, and then I go ahead and create a public-private key pair using the SSH keygen with a blank password in there, or no password. It asks me for a directory to install it in. I'm going to accept the default by just clicking return. It's going to ask to overwrite. I'm going to say no because I've already created it. Now I'm going to copy the public portion of my public-private key into my authorized key directory of the SSH in my home directory. And with that done, I should be able to log in remotely to securely log into my local host directory with the SSH command, no password. And there we go. So we have a login, secure login to my local host without doing any passwords. Next, we're going to download and install Hadoop on our system. Bring up a browser where I have already navigated to the Hadoop site. Click on download, download a release now, and just select the default. From there, I'm going to navigate to the Hadoop 1.2.1 directory. And then select my Hadoop 1.2.1 bin.tar.gz. Now normally I would select this and download it, but I've already done that. It's in my downloads directory itself. So I'll bring that up. I would double click on it. It would open it up, decompress it, and I already have that. So we need to copy this over now to our user Hadoop. And that's just a simple drag and drop. So I'm going to drag the Hadoop 1.2.1 into that, and there we go. We've now downloaded and installed Hadoop onto our system. From here, I got to configure a couple things. We'll bring open a terminal here. Let's see here. Make sure that we're up and running. Make sure that we have the right user groups. It turns out Hadoop does own this, but if you don't have it, it's a simple change owner command with Hadoop. And let's just change the owner there. And then let's check it again here. And looks like, yep, Hadoop is still, we effectively changed the primary owner from Hadoop to Hadoop, but that's how you would change it if Hadoop wasn't your primary owner. The next thing we need to do is we need to configure Hadoop. So I'll go into Hadoop, configure. There are two files, core site and the Hadoop environment. I'll open Hadoop environment in my favorite text editor, which is Komodo. And we have three areas we need to configure. I've already pre-written these things out, so this is copy and paste for me. So first thing I'm going to do is I'm going to copy where my Java home is. I'm very explicit. There are different ways you can do this, but I like to actually identify which Java environment I'm using. In this particular case, I'm using the Mac OS version 1.6, so I'm exporting that. The second thing we need to do is we need to enable the heap size, 2000. We'll just select the defaults. And then the last area we need to work on is suppressing this wrong output due to the JRE's SC Dynamics package. And this is a known issue, and you can research it like I have, and this happens to solve the problem, so we'll set this Hadoop option for the Java runtime, and it seems to suppress it just fine. And that's it for the Hadoop environment. Now we're going to go in and do the core site. You'll see this in the download section. I've already copied between the two configurations is completely blank. So I've already done that off screen. I'll do a quick copy here, and then from there we'll go ahead and paste this in, and you'll have this available in the screen as well. But we have several things we need to do. One is we need to set up a temp directory, which I've just defined as Hadoop.0-0.17.2.1. We also have to set up our file systems names themselves and the port numbers. In this case, I'm running 9000 and 9001, both for the file system and the MapReduce itself. We set up the number of default task, which is going to be 8, and then the number of replications. Since I'm only running a single instance here, I'm just going to run it under 1, and then we save that off. And now for the fun part, we get to see if all this stuff works. So we're going to format the Hadoop distributed file system, bring up a terminal, log in with my secure login here to localhost, and then using the Hadoop command name node-format, we're going to see if we can format our Hadoop distributed file system. And a bunch of fun stuff you can read through here. I think it's worthwhile now and then, but it looks like everything worked, and we have a formatted distributed file system in Hadoop. Let's run a quick test to see if Hadoop's actually running. There's a couple of examples that come pre-packaged with Hadoop. So let's go ahead and log in to our local host. There we go. And I'd like to run the Pi. What we're going to do here is, let me just first check to see if we're in the right directory. I shouldn't have pasted that in there. Let's just do we're in the right directory. I like to change over to Hadoop rather than just typing out Hadoop 1.2.1 all the time. And we're in the Hadoop section. And what we're going to do is we're going to compute Pi using 10 MapReduce functions out to 100 places. That's all we're going to do. And it looks like they're writing out. There we go. And we've estimated the value of Pi out to 10 places using 10 MapReduce functions. Pretty straightforward. Now just to finish this out, we need to shut down our Hadoop cluster using the stop all command. And hit return, and there we go. And it's just shutting down named nodes. And it's stopping out the data nodes. And it's stopping out the secondary name nodes. And we're done. Next part of the process, we're going to download and install R. This should not be a surprise to anybody. I use RStudio personally. We're going to run under 3.0. We just navigate over to RStudio. We click Download Now button. This is a free product. We go over to the Download RStudio. And then we download both RStudio and R. Right? So we click here for R. We click on the Mac. We go down and we select package 3.0.1 and we download that package. From there we can download RStudio 0.97, which is a 64-bit version, and we download that package as well. We download them both, we install them, and then I go and bring up RStudio itself, which is just going under Spotlight, typing in RStudio and bringing it up. There we go. All set to go. Now we need to install RHadoop. We're going to need to install a series of packages on the Mac itself and then install some packages in RStudio. So the first thing we need to do is download from Revolution Analytics RMR2, which is the Hadoop MapReduce framework, R hierarchical distributed file system, and RHbase. All three of these packages will be used in RStudio. You can download them from this link here. With that, we'll go ahead and also download Xcode 463 for its compiler and some of its command line tools. You'll notice that you'll need those when we do some compilations. Now we'll go ahead and open up a terminal. Again, in Spotlight, type in term, select terminal, open it up. I'll go into super user mode. I'll type SU and then the Hadoop username. Enter in my password, which I've blurred out for you guys. You don't need to see that. And now we're in the superheat user mode. What I'm going to do is install Homebrew, which is a automated package download system for the Mac. And I'll just go ahead and paste in the command, which you can find on the website, and go ahead and hit install. A few minutes later, the installation is complete. Type in brew doctor to see if there are any errors. And if we scroll through here, we see most of this stuff is a few missing links, nothing big. These are just warnings. I'm looking for missing compilers. Some links are not found. We can prune these things out with brew prune in the process, but nothing really big in here. So let's go ahead and install one of our first packages, which is going to be Git. And this is going to take some time. And again, so for purposes of expedience, I'll go ahead and speed the film up. Again, a few minutes later, that package is complete. Looking through here to see if there are any significant errors or a few warnings. Nothing we can't live with. Let's go ahead and install package config. This installs fairly quickly. Let's go ahead and install our last package, which is going to be thrift. Okay, and brew install thrift, and a few minutes later, again, time-lapse photography, it's installed as well. You notice here it took 3.5 minutes to get that installed. And that's it. We've installed Homebrew, 3 major packages, and now we're set to move into our RStudio environment. Okay, now we're moving into R, in this case RStudio, where we're going to set 2 environmental parameters. I choose to set them in R themselves. The first is a location of Hadoop. So we'll use the system or the sys.setEnvironment command in R. And then the second is the Hadoop streaming. And we'll set that as well. Both of these are located in the Hadoop directory, one in the bin directory and one in the contrib directory. So we set both of these, and then let's just check make sure that our environment is set right. We'll check to make sure the Hadoop command is set correctly by using the sys.getEnvironment, and it is. Okay, with the environment set, we can now move over and install several packages in R that are going to be needed by RHadoop. There are 9 total packages before we even get to RHadoop, and they're located here in the blog post itself. So we'll just go ahead and make those installs. And you can see here it goes fairly quickly. With those installed, we can move to the 3 packages that constitute the RHadoop, which is the RHDFS, which is the hierarchical distributed file system, and all 3 of these are located in my downloads. This will vary depending upon where you're placing themselves. So we'll go ahead and let that install, and then we install the RBase, RHbase. Again, you can this whole script can be automated. I'm just cutting and pasting here so you can actually see each one install individually so you can get a sense. And we can just see if any errors pop up, which there shouldn't be. And with a little time-lapse photography, that installed correctly. Our last one's going to be our RMR2, which is located in my downloads. And again, with a little bit of editing, that has downloaded and installed correctly as well. Lastly, we'll go ahead with the library command. We'll load each of these packages into R. And there you have it. We've successfully configured R to run our Hadoop environment. All right, well now for the fun stuff. We've got everything installed. Let's go ahead and run a test. And I like running word count, which is a traditional sort of a hello world. I've selected to count all the words in Moby Dick. You can find the complete online text here at the text library. All I've done is taken this file here and saved it off as a text file for use. Let's go ahead and bring up our terminal again. I usually go to Spotlight and type TERM and bring it up. And let's go ahead and securely log into our local host. There we go. And now we need to start up our Hadoop environment. And typically what I like to do is I like to make sure where I am, which is the root level. I move right into the Hadoop directory itself, not one for retyping Hadoop all over. And we're there. And then I usually start with the bin stuff. So we'll just start with bin/start -all.ch or sh, sorry. And in there we're starting up. So you can see here we're starting up our name node, our data node, our secondary name node, and our job tracker, which there won't be any, so it'll shut down again. But that's okay. So everything's up and running right now. So in order for this exercise to work, we've got to move our data into a series of directory, mobydick.txt. So what I'm going to do is I'm going to create a Moby Dick directory in our distributed file server. And I just use the DFS make directory command and give it a path name, in this case Moby Dick. And then I'm going to go in here and just check to make sure that that worked by using the ls command, again, distributed file system -ls. And you can see here we created this user Hadoop Moby Dick directory to store our work. And what I like to do in each of my Hadoop directories, I like to create a data directory, and then I like to create a output directory. So let's go ahead and create another directory in Moby Dick called data. And it's going to be in this directory that we're actually going to copy the text of Moby Dick. So we'll use the copy from local command with the DFS and point it to the text of our Moby Dick, which is in my downloads directory, and then ask it to move it into the Moby Dick directory of our Hadoop file system. And that's all there is to moving files from your local copy into the distributed file command. And if, oops, I just noticed in here I'm missing my data. So I'll just go ahead and type that in there because we did set up a Moby Dick, and within Moby Dick I created a data environment itself, a data directory itself, and then now we'll go ahead and execute that, and we'll check to see that it moved in. So what I'm looking to do is use the distributed file systems ls command and point it to the Moby Dick data directory. And let's see what we have. And there we go. Oh, no such file. Oh, I see what it is. All right. What I... oh, there it is. I used, instead of user, I typed in users here. So let's just go ahead and correct that. So just bring that back and get rid of the S there. There we go. The net is there we go. There's our text Moby Dick copied into our Hadoop distributed, hierarchically distributed file system. Okay, with our data copied over to Hadoop, we can now move back into R, in this case RStudio. And anytime I move into R, I usually like to start from scratch by setting all my environmental factors again and making sure that we've got the libraries installed as well. So I'll just go ahead and copy the set environment commands from before. You can see here that it's set up for the same Hadoop 1.2.1, and I'll go ahead and load the libraries in for our Hadoop, which is the HDFS, RBase, and RM2. You can see here they're all loading in. Now we get to create our map function. Remember, we have a map and reduce function both. We're going to do a word count, and I'll just copy this script. Again, we could have just executed this entire script, but what we're going to do is we'll take a series of lines that it'll be read in, and we'll separate those lines into words, and for each of the words we'll assign it a 1. And that'll be our map function. For each word we do we assign it a key value of 1. Later on we may do the character mapping where we count characters within the document. For now we're just going to go ahead and do the word. Here's our reduce function. The reduce just takes those each individual key value for the words and then summarizes them up. Pretty straightforward. And then lastly, this is our execution function, word count itself, where it's going to take inputs and outputs and execute the function call in there. So you can see here that we're running a text format. We're doing our map reduce. Our map function is map word, and our reduce function is reduce. And so we'll go ahead and execute on that. All right, we need to point our data source to our distributed, hierarchically distributed file system where we stored it. So we add a root command here that just says, look in user Hadoop Moby Dick, which we created. And then we'll go ahead and use file path to create a data path and an output path where we're going to store the results. And that file path just takes our root directory that we had and assigns data for the input and out for the output path. I like to, when I execute my work, I like to wrap it in a systems time just to see how much time it takes. So we'll do the system.time function, and we'll execute this, and we'll store the data in the output path. So let's go ahead and shoot. A little bit of verboseness in here, letting us know what's going on. And here we go. All right, that was it. We counted all the words of the text, and it took us around 1.27 seconds systems time, about 31 seconds total. Let's go ahead and get the data from our output results. So we use the from.dfs command in our Hadoop to get the output data stored in our results file. And with the results in hand, what we can now do is we can now display that results list itself. So what I like to do is I'll create a data frame out of it, and I'll keep the strings as normal strings and not as factors, and then I'll give column headers to column 1 and 2 as words and counts. From there we can go in and take a look at the head, the first 6 lines. You can see here we have words in our first column and counts in the second, but I like to see the most prevalent words in Moby Dick. So what we can do is we can do an order command on the results themselves, and that's fairly straightforward. And that's just taking the results and then using the order command with the negative in front of the results df $count, the count column, to order in descending order. You can see here the most prevalent word is the, around 13,600, 13,700, and then this is actually a double space here. Turns out to occur after every period in the document, which is kind of interesting itself. And that's it. That's a complete end-to-end implementation of RHadoop from scratch, and then parsing out the word counts in Moby Dick. The last thing we're going to have to do is shut this down, and we're going to do that next. To shut down our environment, all we need to do is terminate R, go back into the terminal mode here, and then in the bin directory we just need to execute the command stop all .sh. And you can see here we're stopping. There's no job tracker to stop, and it's going to stop the name node. Once it shuts that down, I'll do the data node, and then eventually move in here to the secondary name node. And that's all it takes to shut down a Hadoop system. And that, folks, is how you not only integrate R with Hadoop, but use it to count the number of words in a text document. So until next time, this is Dr. Jerry A. Smith for Dr. J's Forays into Data Science.